MIG and stick welding are two widely used techniques, each with distinct advantages depending on the job. Here's a breakdown of their key differences. Process and equipment. MIG welding, metal inert gas, uses a continuously fed wire electrode. Requires an external shielding gas like argon or CO2. Easier to automate and ideal for clean indoor environments. Stick welding, shielded metal arc welding or SMAW, uses a consumable electrode coated in flux. The flux burns to create its own shielding gas. More manual and rugged, suitable for outdoor or dirty conditions too. Ease of use. MIG. Beginner-friendly with a simple trigger start. Requires clean metal surfaces for best results. Less post-weld cleanup due to minimal spatter. Stick. Easier to set up and more forgiving of rust, paint, or dirt. Requires more skill to control the arc and avoid sticking. Produces slag that must be chipped away after welding. Environmental suitability. MIG. Sensitive to wind due to reliance on shielding gas. Best used indoors or in controlled environments. Stick performs well in windy or outdoor conditions. Ideal for field repairs and construction sites. Material compatibility. MIG. Great for thin metals down to 24 gauge. Works well with aluminum, stainless steel, and mild steel. Stick. Better for thicker materials, 1/8 and up. Stronger welds on cast iron and heavy steel too. Cost and portability. MIG. Higher equipment costs due to gas tanks and wire feed systems. Less portable and more complex setup. Stick, lower cost and highly portable. Minimal gear needed, just a welder and electrodes. There's a whole spectrum of welding helmets out there, each tailored to different needs, preferences, and budgets. Here's a breakdown of the main types to help you find your perfect match. Common types of welding helmets. Type key features, pros, cons. Passive helmets. Fixed shade lens, usually number 10. No electronics. Affordable, durable, reliable. Must be flipped up, down manually. Limited visibility. Auto darkening helmets. Lens adjusts automatically to arc brightness. Convenient, safer, better visibility. More expensive, requires power source. Fixed shade, auto darkening. Auto darkens to one preset shade. Simpler than variable shade, still hands-free, less versatile for different welding types. Variable shade helmets, adjustable shade range, e.g. Thermarate Hour 13. Ideal for multiple welding processes, TIG, MIG, etc. Higher cost, battery or solar powered. Solar-powered helmets uses solar cells to power auto-darkening lens. Eco-friendly, low maintenance. Needs sunlight to recharge, may not be ready instantly. Battery-powered helmets uses replaceable or rechargeable batteries. Reliable, consistent power battery replacement needed, heavier than solar. Helmet with cheater lens. Built-in magnifying lens for precision work. Great for detailed welding. May not suit all users or helmet models. Pro tip: if you're doing low-amp TIG welding or switching between processes, a variable shade auto-darkening helmet with multiple sensors and a wide viewing area is a game changer. Models like the Lincoln Viking 3350 or Clutch Monster View 2700 offer top-tier clarity and comfort. Preheating metal before stick welding can significantly improve weld quality, especially when working with thicker sections or materials prone to cracking. Here's a breakdown of why and how to do it effectively. Why preheat? Reduce cracking. Preheating slows the cooling rate, minimizing the risk of hydrogen-induced cracking. Improve fusion. It helps the weld penetrate deeper and bond better with the base metal. Lower thermal shock. Gradual heating reduces stress from sudden temperature changes. How to preheat. Use a torch or oven. Propane torches are common for field work. Ovens are used in controlled environments. Target temperature. Depends on the metal. Mild steel may need 100-300 degrees, while cast iron or high-carbon steels require more. Measure accurately. Use temperature indicating crayons or infrared thermometers to ensure consistency. Preheating isn't always necessary, but when it is, it can be the difference between a strong, clean weld and a brittle, cracked one.
You'll need a range of safety gear to protect yourself while welding, including eye and face protection. Welding helmet. This is crucial for protecting your eyes and face from intense light, UV and infrared radiation, sparks, and debris. Auto-darkening helmets are popular as they automatically adjust the shade level. Safety glasses or goggles. Wear these even under your helmet to provide an extra layer of protection from flying particles and debris. Hand protection. Welding gloves. Choose gloves designed for welding that are heat and flame resistant. Different types of welding may require different gloves, such as those for MIG, TIG, or stick welding, according to Apex Technical School. Ensure the gloves cover your hands, wrists, and lower forearms. Body protection. Welding jacket or apron. Opt for flame-resistant materials like leather or treated cotton to protect your body and arms from sparks and heat. Leather offers robust protection, while flame-resistant cotton can be a more comfortable option in warmer climates. Make sure your clothing is free of oils or gasoline, which are highly combustible. Avoid wearing clothing made from synthetic materials as they can melt and cause severe burns. Consider wearing cuffless pants made of flame-resistant material to prevent sparks from being trapped. Foot protection. High-top leather boots. These protect your feet and ankles from falling objects, sparks, and hot metal slag. Ensure the boots have rubber soles and, ideally, a steel plate above the sole. Respiratory protection. Respirator. If ventilation is insufficient, you may need a respirator to filter out harmful welding fumes and particulates. Powered air purifying respirators, PAPRs, are often considered the gold standard for welding applications. Hearing protection. Earplugs or earmuffs. Welding can be noisy, so protect your hearing with earplugs or earmuffs.